Welcome to Study Loop.
Our question says that two vectors, vector v1 and vector v2, add to resultant, which I have written here under given as vector v is equal to vector v1 plus vector v2. And then the question says describe vector v1 and vector v2 if a, v equals v1 plus v2, b, v squared equals v1 squared plus v2 squared, and c, v1 plus v2 is equal to v1 minus v2. So I also wrote here under A, B, and C in red what we were given. And then I'm going to solve this out in black and write the solution in black here. So for part A, in order for the magnitudes to be able to add linearly the way that they are portraying, the two vectors must be parallel to one another. So we can go ahead and write next to here the answer that the two vectors, vector v1, must be parallel. That's what that symbol represents, to vector v2. Okay, and that's the actually answer for part A. Then for part B, what we can understand, in order for these vectors v1 squared plus v squared to equal v squared, and in order for this to be true and for these vectors to be able to add according to Pythagorean theorem, they must be at right angles to each other, right? Because that would mean this one is v1, v2, and if v1 squared plus v2 squared is equal to v squared, that would be that. That must mean this is a right angle. So we can say, according to B, that v1 is perpendicular to v2, where these are both vectors. So we got to give them their vector symbol and box that in as our solution for part B. Okay, now for v1 plus v2 to equal v1 minus v2, the only way that can be true is if v2 is equal to 0, okay? Because if v2 is equal to v1, then the left side would be 2v1, and then the right side would be 0, so that can't be true. If v1 is equal to minus v2, the left side would be 0, but the right side would be minus v2, so that can't be true. So the only way for this to be true is if v2 vector is equal to 0. Okay, box that in as our solution to part C.